Hey everybody. Today we're talking about experiments and observational studies, talking about some best practices for each one. So experiments and observational studies are the two fundamental sorts of research studies, and the big difference between the two is that in an experiment, different treatments are applied to different parts of the sample, and the variations are noted. By doing this, you should be able to hopefully determine if a treatment is having an effect. So the point of an experiment really is hopefully to determine cause and effect. You can't always do an experiment for various reasons, some of them ethical, some of them practical. Sometimes you're limited to an observational study, and that's where the researchers are just measuring characteristics of the population of interest without attempting to influence the responses in any way. And the most common sort here is the survey. Here's a few examples. In each case, let's determine whether we have an experiment or an observational study. My advice is to pause the video in between each one and try and come up with an answer before hearing mine. A group of doctors studies the effects of a new cholesterol-lowering medication by giving it to their patients who have high blood pressure. So this is an experiment. There is a treatment being applied. It isn't a particularly great one because there aren't different groups being studied, so cause and effect will be hard to determine. And we'll get to talk about some of the details of how to improve this process later in this vid. Second, a primatologist observes 10 chimpanzees in their natural habitat, taking careful notes about the social behavior. So this is an observational study. They're not making any changes to their environment, not trying to apply treatment to one group or another. Third, a pollster contacts 500 men and 500 women, asking each individual which candidate they support in an upcoming election. So this is another observational study where we are not applying a treatment, not seeing the effect of that on the sample that we have. Now, there are still two different groups here. The difference between an experiment and an observational study isn't that we have groups or not. It's whether there's a treatment being applied to at least one of the groups. So a good experiment should be randomized, controlled, and replicable. That's sort of the holy trinity of good experimentation. And so we'll say a few words about each one of these. Randomization in an experiment means that research subjects, whether those are human or otherwise, are randomly assigned to treatment groups. In particular, neither the researcher nor the subject should decide who will receive which treatment. This is getting to control, which is the next thing we're going to talk about. A good experiment should be controlled, and this means that the different treatment groups should be as identical as possible, except for the specific treatments they receive. If the results are different at the end of the experiment, we'd like to be able to point to the treatment and say that's the reason. So thinking about randomization as it relates to this, if we allow the subjects to select which group they're in, then there's another variable in there, which group they have chosen. Why have they chosen it? Are they different in some way? Similarly, if we allow the researcher to decide, we could run into similar issues. All of these things are confounding variables, alternative explanations for the differences between the groups at the end of our experiment. Again, at the end of our experiment, we'd like to be able to point to the treatment as the cause. Finally, a good experiment should be replicable, and that means that we can do the experiment again and expect fairly similar results. If an experiment can't be replicated, it's going to have fairly low value. Another common technique that's used in good experiments is blocking. Often, researchers have reason to suspect that different sorts of subjects might respond differently to an experiment. And in a case like that, you take the different sorts of subjects, put them in different groups, even before you start your study. For instance, modern medical studies often use demographic factors, in particular biological sex, as blocking variables, and that helps us ensure that the treatments which are being studied are safe and effective across potentially very different populations. There are any number of medications, for instance, that affect men and women differently. Good experiments typically involve comparisons between two or more treatment groups. Usually one of those groups receives no intervention at all, so as to provide a baseline for comparison. This is called the control group. Notice that I'm using the word control in a very slightly different way here than I was a slide or two ago. The control group is supposed to help give us control over the variables in our study. Unfortunately, subjects in research studies often respond even to treatments that are known to have no measurable effect. And this is called the placebo effect. For instance, if a student believes that they're receiving an experimental lesson plan, they may respond well on the exam. They may go into it with a little bit more confidence and may score better, even if the new lessons were no better than the old ones. Experimenters should always attempt to control for the placebo effect. One of the most important ways that they do this is by giving the control group a placebo treatment. Not just no treatment, but a placebo treatment. One which is known to have no real effect. So in medical trials, that could be a water pill. In the example from the last slide, we could be talking about a lesson plan that's just unrelated to the material being taught. Once again, I'm using the word placebo in a slightly different way here than I was a second ago. Placebo, the object, the water pill, the lesson plan, whatever, slightly different from the placebo effect that I talked about a moment ago. Not only should the assignment of subjects to treatment groups be random, but whenever possible, it should be double-blind. This means that neither the subjects nor the people collecting the data should be aware of who is in which group. And that's an essential element of good experimental control. Let's take the two aspects of blinding one at a time. First of all, subjects that know that they're receiving a placebo treatment will often respond differently than ones who don't know that. If you have subjects that know they're getting a placebo treatment, you're not going to observe the placebo effect anymore. They may as well not be having any treatment whatsoever. Similarly, for subjects that know that they're receiving an experimental treatment. On the other hand, researchers who know which subjects are receiving a real treatment versus a placebo may inadvertently or even intentionally observe results differently. For instance, they might tend to round measurements differently or be liable to note behavioral changes more or less aggressively, even if they're not intending to, even if they are coming in with the best intentions of being completely objective. 3 more important bits of terminology to know about experimental design. First of all, completely randomized design is a design in which subjects are simply placed into treatment groups at random. In contrast is randomized block design, in which subjects are first broken down into groups based on some characteristic, like age or gender, and then assigned to treatment groups at random. So we have a placebo group for men and women, and we have a treatment group for men and women for that experimental medication or treatment. This potentially allows researchers to determine how the treatment is affecting different groups differently. Finally, matched pair design, in which subjects are paired by similarity 1-to-1 before being randomly assigned to treatment groups. The advantage of this is that at the end of the study, you can take those pairs and match them back up again and compare them 1-to-1 and hopefully get some very specific results about the differences between the groups.